Hey, it's Mrs. Francis here, and today we're going to be looking at a binomial expansion using Pascal's triangle. So let's get started. So first, we have a problem here where we're being asked to expand a binomial a minus 2 to the fourth. And if we go about it the usual, the old-fashioned way, we would write out a minus 2 4 times. We would use FOIL, we would get two trinomials, we would use our distributive property, and we would get our solution. The problem with this is that it could cause errors pretty easily, and it's a little tedious. So what I want to do is show you a different way where if we look at some patterns, we might make this whole process a little easier. All right, so let's go ahead and do that. And the first thing we're going to do is we're going to look at a plus b expanded. And I have it to the 0 power. Anything to the 0 power is 1. Obviously, a plus b to the first is just going to be a plus b, and so forth. And we're going to look at the coefficients in this expansion. And if you look at the coefficients just on their own, you start to see some patterns. And one of the patterns we see is that we have all ones down the side. So we have ones down the left side, and we have ones down the right side. Another thing you're going to notice is if you add the two numbers above, you're going to get the answer for the next row. So 1 and 1 is 2, 1 and 2 is 3. And that is true as we continue to expand a plus b, even to the 5th power. You can get the next row by looking at the row above and just adding the two numbers above it. So what we've identified here by doing that is something called Pascal's triangle. And I just want you to notice right here that we start at a plus b to the 0 power. So the first row of Pascal's triangle is just 1. The second row is 1 and 1, and so forth. All right, now we're going to look at the exponents in each term and see if we can come up with a pattern there. And I'm going to add, for example, I'm going to add a b to the 0 power to this term right here because I want to see an a and b in each term so I can understand what's happening with the exponents. And I've done that here. I just want you to notice that I am going to call n the exponent of the binomial. And we're going to look at and see what happens in each term to all the exponents based on what n is. So the first thing we're going to notice is that for the first term in the binomial, the exponent starts at n and it goes down to 0. So if n is 3, the first term is going to start at 3 and go down to 0. The next thing we're going to notice is the second term of the binomial, in this case it's b, is going to start at 0 and go up to n. So in this case, 0, 1, 2, and 3. And that's true for any of these when you're doing it in expansion. There are n plus 1 terms in the expansion. So if we have a plus b to the third, we're going to have 4 terms. If we have a plus b to the second, we're going to have 3 terms. We're always going to use the n plus 1 row of Pascal's triangle. So if we want to know what the coefficients are for a plus b to the third, we're going to use the 4th row of Pascal's triangle, and the coefficients would be 1, 3, 3, and 1 in that case. And lastly, it's helpful to notice that the exponents in each term are always going to add up to n. So if n is 3, 3 plus 0 is 3, 2 plus 1 is 3, 1 plus 2 is 3, and 0 plus 3 is 3. And that's just a nice way to check yourself as you work through this. All right, so we're back to our original problem, and here's the answer that we got. And now we're going to use our new method for expanding a binomial. So we're going to look at Pascal's triangle. We're going to pull the 5th row because this is to the 4th power, and we're going to write down those coefficients. Then we're going to take a, and starting with 4 and going down to 0. And then we're going to take -2, starting at 0 and going up to 4, and then put plus in between each term. Now the last part, you're going to just make sure you simplify because this is a little sloppy the way it is now. And we're going to just use multiplication between each part of the term. So in this case, we have 1 times 1, so we're going to get 1. Here we have -2 times 4, so we're going to get -8, and so forth. And so we've completed the expansion I think without all the tedious work of using FOIL and distributive property and so forth. And the more you do these, the easier they're going to get. So that's it for today. Hope it was helpful. You can do it. Let me know how it goes.